Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. And I hope I'm perfectly audible and visible to each and everyone present over here. Okay, fine. So we are moving to our next part of the same chapter, chemical bonding. So in the first few classes, we have already seen what you mean by the chemical bonding. What is the introduction part for the chemical bonding? Then we have seen ionic bond as well as the covalent bond, right? So now, today in this session, we are going to discuss about the bond parameters, how we can express the chemical bond in terms of some parameters like bond length, bond order and so on. Hi Arush, good evening. So here are the main bond parameters we are going to discuss today: bond length, bond energy or bond enthalpy, and bond angle and bond order. We need to focus mainly on these four parameters, how it is explained in the chemical bond nature, how it is explained, right? How bond order is related to bond strength, bond energy and so on. So do you have any idea about the bond parameters, how we can explain bond parameters? If you have idea about the bond order, bond length or bond energy, we can just predict the bond, right? Whether it is covalent bond or the ionic bond. So the bond parameter is defined as it is the characterization of the bond on the basis of various parameters like bond length, bond angle and bond enthalpy. Just giving a brief introduction about that. These are the parameters we are going to discuss one by one. So here is our first parameter. What you mean by bond length? I think in the the periodic table chapter we have already seen the different length, right? We have already seen the radius. Same as that of here, we are expressing the radius or the length of the bond in terms of bond length. So I hope you can see the image here, right? These are the two atoms. So the bond length is defined as the distance between the nuclei. This is our nuclei of the two bonded atoms. Here the molecule is formed between two atoms A and B, right? This RA stands for the radius of the first atom A and RB stands for the radius of the second atom B. So this is the equilibrium distance between the nuclei of two bonded atoms in a molecule is known as the bond length. I hope you understand what is the exact meaning of bond length. It is a distance, right? If you are mixing two atoms together, we will be getting a molecule. So this is the equilibrium distance between the nuclei of two atoms in a molecule, or it is given as RA stands for the radius of the first atom and RB stands for the radius of the second atom. So total bond length will be equal to the sum of RA and RB. Is that clear? Just let me know in the comments if it is clear or not. Yes, it is given here. It is generally expressed in terms of angstrom units. Maybe you must have studied in the physics chapters, right? What is the unit of distance? So angstrom stands for, it is equal to 10 to the power minus 10 meters. So angstrom is equal to 10 to the power minus 10 meter, or it is equal to 10 to the power minus 12. So these are the two units for the unit of the bond length. Either we can express in terms of angstrom unit. Angstrom is equal to 10 to the power minus 10 meter, or picometer. PM stands for the picometer. It is given equal to 10 to the power minus 12 meter. Otherwise, we can write it as 1 angstrom is equal to 10 square or 100 picometer. I hope you understand. So this is a general bond as well as their bond length or distance in the picometer given here. If you are taking single bonds, we have already seen in the case of carbon and its compound, carbon will be forming multiple bonds and the single bonds, right? If you are having the compound which is containing only single bonds, their bond length will be equal to 154 picometer. PM stands for the picometer here. Then in the case of carbon nitrogen bond, the bond length will be 147. and for carbon and oxygen it will be 143, and for carbon and fluorine it will be 142. If it is a double bond, it will be having 133 picometer as the bond length, but for a triple bond it will be having 121. So as you can compare here, if you are taking single bond, double bond and triple bond, which one will be having the more bond length? So this is the main question you can expect in your board examination or the JEE examination, which one will be more strength. Just compare the values of single bond, double bond and the triple bond. The last one is a triple bond. Which one is having more value here? It is already given in the table. Yes, single bond, right? So single bond strength will be maximum, then double bond, then triple bond, right? Just keep this thing in your mind. While we are discussing about the bond order, we need to compare the bond length as well as the bond order. I hope you understand. If you are taking the bond length order in the case of single bond, double bond, triple bond, the single bond will be having more bond length of 154 picometer, but for second double bond it will be 133, then for triple bond it is 121. While we are discussing about the bond order, you must have an idea about how bond length is connected with the bond order by using the same example. So that's all about the first bond parameter, that is about the bond length. Now we are going to discuss about the next parameter, bond enthalpy. Arush, I didn't get your question. Did you study any concept of equilibrium here? So what do you mean by bond enthalpy? It may be the energy change, right? It may be the energy change. Okay, in the case of bond enthalpy means the energy change happens when the bond is broken, right? So there will be two types of bond enthalpy, similar for the same molecule, but if you are taking the diatomic molecule, there will be some difference in their concept. So if I am taking diatomic molecule, as we already know, diatomic molecule means they are formed by two atoms only. For example, if you are taking as hydrogen, right, H2 molecule, if you are taking the hydrogen molecule, as we already know, this hydrogen molecule can be break into two hydrogen atoms, right? So the energy required to break 1 mole of diatomic molecules in the gaseous state into their free constituent atoms is called the bond enthalpy. Just think about here, if you are taking the hydrogen molecule, diatomic molecule, right? The energy required to break these hydrogen molecule into single hydrogen atoms is known as the bond energy for the diatomic molecule. Is that clear? And the value for this bond energy is already given here. It is 436 kilojoule per mole. Unit will be always given in the terms of kilojoule per mole or kilojoule mole inverse. So from the value of bond enthalpy, you can identify whether the process is absorbing energy or liberating energy. If the value of delta H or the bond enthalpy value is positive, we can say that this process involves they absorbs the energy, right? So it will be energy absorbing. That's why they are having the positive value of 436 kilojoule per mole as the bond enthalpy here. Similarly, if you are taking the chlorine molecule, as we already know, right? Cl2 molecule, diatomic molecule, it is going to be break into its the constituent ions, chlorine atoms or chlorine ions. So it will be forming, yes, 2Cl, it will be forming 2Cl atoms or ions. They will be forming getting the bond enthalpy value as 242 kilojoule per mole, or again it is positive value, energy is absorbing. Clear? And just to compare the data, they have given the bond length also. For hydrogen bond length, it is 74 picometer, and for chlorine bond length, it will be 198 picometer. There is no need to memorize the complete data here. You just want an idea that what you mean by the bond enthalpy or the bond energy for the diatomic molecule. It will be always positive because they are absorbing the energy. this is about the case of diatomic molecule. If you are taking the polyatomic molecule, which means that the molecule which is containing more than two atoms, there will be another concept behind the bond enthalpy or the bond energy. Okay. Let us take about the case of water molecule, right? First, the water molecule is break into H and OH minus ion, hydrogen and OH. Then it will be having the first bond enthalpy as 502 kilojoule per mole. Then again, these OH is break into hydrogen and oxygen. So in case of H2O molecule, the enthalpy needed to break two OH bonds is not the same. As you can see over here, they have the different values of 502 and 427 kilojoule per mole. So that we can define the bond energy or the bond enthalpy for the polyatomic molecule as it will be the average of the various bond dissociation energies of the similar bonds of it. No need to worry, just focus on the water molecule here. There will be two processes happen. In the case of water molecule, it will be dividing into hydrogen and OH minus ion, right? So they will be having the first value of 502. Then this OH is break into hydrogen and oxygen, simply having another value of 427. If you want to finally find out the bond dissociation enthalpy of the polyatomic molecule, which means they are containing more than two atoms, we just want to take the average of these two values. That's why I'm taking here 502 plus 427 by 2 will be equal to 464.5 kilojoule per mole, which will be the bond dissociation enthalpy of the polyatomic molecule water here. Hi Arpit. Okay, Bhavana, which point I want to repeat here? Diatomic molecule or polyatomic molecule? I'm just repeating again in the case of diatomic molecule. It is simply the amount of energy required to break the bond, right? For example, if you are taking the diatomic molecule like hydrogen molecule, it will be break to two hydrogen atoms by using the energy of 436 kilojoule per mole, which is positive value, which means that this process is always absorbing the energy, right? Absorbing the energy. This is simply in case of diatomic molecule. But in the case of polyatomic molecule, there will be different energies for the different bond breaking, right? If you are taking the water molecule, there will be two processes happening. What is first one? Water molecule is break into hydrogen gas and the OH gas here. For that, first value of energy will be 502 kilojoule per mole. Then the second one, this OH is again break into hydrogen and oxygen. This is the process in case of water molecule. So the second energy will be equal to 427 kilojoule per mole. If you want to find out the complete or final bond dissociation enthalpy for these polyatomic molecule, we need to take the average of the various bond dissociation energies of the similar bonds, right? So that will be equal to the sum of, if you are taking the average, 502 plus 427 by 2 is equal to 464.5 kilojoule per mole in the case of water molecule. Similarly, if you are taking any another molecule, it depends on the bond dissociation there. What is the bond dissociation energy for the different steps? Find over there. I hope you understand. Now we are moving to the third parameter, that is about the bond angle. So from the name itself, it is suggesting that it's the angle between bonds, right? Angle between bonds. So we can just define the bond angle as while you are studying more detail about the chemical bonding, you will be moving to the molecular orbital theory about the orbital and their shape. Then you can understand what you mean by the orbitals, right? What you mean by the orbital or the orbital overlapping. For the just understanding of the bond angle, you just want to memorize these things as these are angle between the orbitals containing bonding electron pairs around the central atom in a molecule or a complex ion. No need to worry, it is the angle between the bonding atoms. For example, if you are taking the water molecule, this is the bond angle. This is the bond angle between the hydrogen, oxygen, hydrogen atoms, right? So that will be having the particular value for different molecules given here. While we are discussing about in detail about the orbital overlap theory, you will get a proper idea about the sentence given here, because bond angle is depending upon the shape. If the shape changes, bond angle is obviously changes. This is the case of water molecule. This is a angle in between these the bonded atoms to the central atom. Here oxygen will be the central atom and hydrogen are the bonded atoms here, right? This is the angle between bonded atoms and the central atoms here. So common examples are given here. In general, bond angle will be expressed in terms of degree, right? So in the case of water molecule, this H or H bond will be 104.5 degree. You want to memorize these things here. In the case of water molecule, bond angle is equal to 104.5 degree. While you are discussing about the VSEPR theory, this is a very important theory which we are going to discuss in the chemical bonding chapter. So depending upon the lone pairs, there will be changes in their bond angle. So here in general, water molecule will be, we are expecting water molecule will be having an angle of 109 degree, but because of the presence of these two lone pairs, bond angle will be decreases to 104.5 degree in the case of water molecule. Similarly, in the case of CH4, right? CH4, it is a general shape will be tetrahedral. After completing the VSEPR theory, you will get an idea about the shape of this molecule also. And this will be bend shape or V shape. This will be tetrahedral shape. Normal tetrahedral angle is 109 degree 28 minutes. This is the unit of bond angle, right? Either expressed in terms of degree or minute. So it is 109 degree 28 minutes. The bond angle between carbon and two hydrogen atoms. Is that clear? So common data is given here. If you are taking the CH4 molecule, methane molecule, structure is already given, shape is tetrahedral. The bond angle will be 109 degree 28 minutes. Then for the C2H4, while we are discussing about the carbon compounds, we have already seen the hybridization as well as the shape of the C2H4 molecule, right? C2H4 molecule means CH2 double bond CH2. So it will be having a triangle planar shape with bond angle 120 degree. It's a double bonded carbon compound. Then C2H2 means it's an alkane, right? Ethyne, having a triple bond in between the carbon atoms. So C2H2, CH triple bond CH. It will be having a shape of linear. Linear shape means it will be having the bond angle similar to the straight line, that is equal to 180 degree. So this is all about the part of third parameter, that is about the bond angle. I hope you understand. I am repeating again, bond angle is the angle expressed in between the central atom and the two bonded atoms. If you are having two bonded atoms, it will be the angle between the bonded atoms and the central atom here. So in general, in the case of methane molecule, it will be having the shape tetrahedral. Bond angle is 109 degree 28 minutes. Then if you are discussing about the VSEPR theory, you will get a proper idea about the bond angle and their valence shell electron pair. So if you have any lone pairs in any of the molecule, this bond angle will be changes. That the example is given in the case of water molecule. Because of the presence of two lone pairs, the bond, we will be expecting the bond angle as 109 degree, but it will be changes to 104.5 degree because of the presence of these two lone pairs in the case of water molecule. Then in the case of ethyne, right? In the case of ethyne, it is 180 degree because the shape is linear, and for ethene, double bonded carbon, it is 120 degree triangular planar shape. So bond angle is completely depends upon the shape of the molecule. Depending upon the shape, bond angle will be changes. Now we are moving to the last parameter, that is about the bond order. So what do you mean by the bond order? Is there any idea? So in the first class, we have already seen how to draw the Lewis structures of any molecule, right? We have already seen some rules to find out the Lewis structure of the any molecule, right? So from that, we can identify the Hi Saksham. So from that we can identify the number of lone pairs as well as the number of bond pairs, right, while drawing the Lewis dot structure. So in the case of Lewis dot structure, for the description of the covalent bond, the bond order is given by the number of bonds formed between the two atoms in a molecule. For example, if you are taking the fluorine molecule, I hope you can see the diagram here. We have already seen how to draw the Lewis dot structure for the F2 molecule, right? There will be one bond is formed between fluorine atoms and the remaining electrons are the valence electrons, right? They are the lone pairs. So here you can see what will be the number of bonds formed between two fluorine atoms. It is equal to 1, right? So that will be the bond order for this fluorine molecule. The number of bonds formed between two atoms in a molecule is known as the bond order. That is equal to 1 here in the case of fluorine molecule. Then if you are taking the oxygen molecule, while drawing the Lewis dot structure, you can identify that oxygen will be having two bonds in between the two oxygen atoms. So the bond order for oxygen is equal to 2 here. Then if you are drawing the structure for N2 molecule, it will be having 3 bonds in between, which means bond order of nitrogen molecule is equal to 3 here. Clear? Okay, is there any doubt regarding the bond order? Then one more point you have to keep in mind, that in the case of competitive examination point of view, you just want to identify the bond order of some molecules. So as we already know, isoelectronic species, right? Isoelectronic species means those molecules, they are having the same number of electrons. So those molecules which are having the same number of electrons is known as the isoelectronic species. So they will be having the same bond order or the identical bond order. For example, if you are taking F2 molecule, right? F2 molecule, what is the total number of electrons there? In the case of F2 molecule, hi Saksham, I am good. So how we can find out the total number of electrons in a molecule? As we already know, fluorine will be having 9 electrons, right? Their atomic number is 9, so total electrons will be present in the case of one fluorine atom is 9 electrons. So here fluorine molecule means 2 fluorine atoms are combined to form the fluorine molecule. So total electrons will be equal to 2 into 9, that is equal to 18 electrons, right? Now we are taking the O2 2 minus, right? O2 2 minus. For one oxygen atom, it will be having 8 electrons. Atomic number is 8. For 2 oxygen atom, it will be 2 into 8, right? 2 into 8 means 16. Then 2 minus means 2 electrons are adding to the oxygen molecule. That is why they are forming the anion here, O2 2 minus. So I am just adding 2 electrons here. So total 2 into 8, 16 plus 2, that is equal to 18 electron. Which means that these two molecules are isoelectronic. Isoelectronic means they will be having the same number of electrons. That is here 18 electrons. So if you are comparing the bond order, if you want to find out the bond order of O2 2 minus, it will be similar to the bond order of F2 molecule. For F2 molecule, bond order is 1. So for O2 2 minus also bond order is 1. Is the point clear to everyone? So same example, same type of example is already given here. If you are comparing the electron, total number of electrons in the case of N2, CO and NO plus molecule, you can identify that it will be having total 14 electrons in it. For N2 molecule, bond order is 3, so that CO and NO plus will be having the same number of electrons of 14 here. So they will be also having the bond order of 3. So this point is very important in terms of JEE or NEET examination point of view. So that's all about the bond parameters. We have already seen bond length, bond order, bond angle and the bond enthalpy. Now let us practice some questions based on the topic we have studied today. So here is the first question. Just let me know what is the answer in comments. Which of the following best describes the bond length? 4 options are already given here. At least give me random guesses. A, B, C or D. What is the exact definition for the bond length? So option A will be the correct answer. This is the distance between the nuclei of two bonded atoms, as we already know. If you are taking any of the atoms, comparing if two atoms are combined to form the corresponding molecule, it will be the distance between the nuclei of two bonded atoms. It is given as the sum of radius of the individual atoms. Here is the second question. Bond energy is defined as, what is the exact definition for the bond energy? Again, this is the energy required to break a bond, right? Bond dissociation enthalpy or the bond energy. The energy required to break a bond, depending upon the diatomic molecule or the polyatomic molecule, the change will be happens. For the diatomic molecule, it will be the simply the bond required to break the atoms into the molecule. And in the case of polyatomic molecule, it will be the average energy between the bond dissociation happening there. Here is the next question. Which of the following bond is expected to be the shortest? So indirectly they are asking about the case of bond length. So which one will be having the very less value for the bond length here? It will be C triple bond C, right? As we already know, 121 picometer is the bond length for the triple bond here. Then one more point you have to keep in mind, that we can just find out the relation between bond order and the bond length. So this is the relationship between bond order as well as the bond length and bond enthalpy, right? If you have the bond order more, it will be having the more bond enthalpy here. So if you are comparing C single bond, C double bond and C triple bond C, which one will be having the more bond order? Bond order means number of bonds formed between the atoms. So if you are comparing single and multiple bonds, C triple bond C will be having the more bond order. So more bond order will be having more bond enthalpy. So here bond enthalpy is higher. If you are comparing the bond length, it will be having less bond length, because bond length is inversely proportional to bond order. Bond order is maximum here, which will means they will be having the very less bond length here. So this is also very important in your examination point of view. You can expect more questions based on the relationship between bond order, bond strength, bond enthalpy and the bond length. The only point is that bond order is directly proportional to bond enthalpy, bond strength and the bond angle, but it is inversely proportional to the bond length. You can just remember by using the example of C double bond C, C double bond C, triple bond C and the C single bond C. So here is some previous year question, just repeating again about the case of bond length. What is meant by bond length and how is it related to the bond order? We have already seen, right? Bond length is defined as the distance between the nuclei of two bonded atoms. Higher bond order means shorter bond length due to the strong attractive forces. In words, we can just given as bond order is inversely proportional to bond length. Okay, that's all about from my side for today about the bond parameters. We have already seen 4 parameters, right? They are responsible for the bond formation there. So if you're asking about the bond order, bond length and bond enthalpy as well as the bond angle, there will be the four bond parameters, how they are related to each other. So bond order is the number of bonds formed between the atoms in a molecule, and bond enthalpy is the energy required to break 1 mole of a molecule to corresponding atoms, and bond strength, right? Bond strength is also there. Bond angle is the angle formed between the central atom as well as the bonded atoms. The last one is about the bond length, right? Bond length is the distance between the nuclei of 2 bonded atoms in a molecule. So there is a general reminder about the SCORE examination. Sri Chaitanya Academy is providing an international level scholarship examination for the students from grade 3 to 12 is also available. Then the opportunities are here about the 2.5 crore of cash rewards, 350 crore around the scholarships is there, NASA trips, exciting gadgets, and up to 100% scholarships are also provided there. So the exam date is on September 28. You just want to register before 26. 26 is the last day to register the examination. The link will be provided in our description. You can just register right now for the examination. There will be online as well as offline examination are possible. So if you want to join the offline examination, you can just go to your nearby Sri Chaitanya Academy. They will be providing the registration forms there. Then if you want to attend the online examination, just visit our website. We will be providing the description. You can just register there. So this is an exciting opportunity for the students from grade 3 to 11. So don't miss this opportunity. So I hope you guys enjoyed the session. If you really like the session, hit the like button, share this particular session to your friends also, and subscribe our channel, Infinity Learn 9 and 10 YouTube channel. If you want to get the session PDF, you need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. The session PDF will be provided there after all the classes. So thank you so much all of you. See you in the next class. Bye bye.